Hello everyone and welcome to Synology 2022. I'm Richard White and I will be taking you through our security session. Thousands of security breaches occur each day, causing significant financial, reputational and even emotional damage. We continue to develop robust and sophisticated security solutions that protect the data stored on your NAS. There's a lot to consider when you deploy solutions for businesses. Even for personal use, security and privacy are important things that we value in the products and services we choose. At Synology, security and privacy are key pillars in how we build and design our products. And we are continuously improving the way we do things to make sure the final product meets the very high standards that both we and our customers expect. Let's take a quick look at the very beginning of the pipeline, from the development side. Security by design. We set off and architect our products to be inherently secured. This includes under-the-hood things like the encryption implementation or how our services securely handle your credentials and private data. And also more obvious things to the user, from hard limitations on setup, like username, password strength, to reminders about security, for example, our security advisor, and in the speed of executing patches to protect us from external threats, like frag attacks, Eternal Blue, etc. Security is something that starts but never finishes. It's a multi-step, multi-layer objective. There's no silver bullet and no one-size-fits-all type of guidebook. Initiatives that we at Synology have been working on and are continuously improving to give our users the best security. Organizational improvements include both important system level and company changes to improve product security. Protocol modernization is straightforward, where we upgrade or completely revamp the way we do things to adhere to the new best practice. Bounty programs. One of the best ways for companies to improve their security is to work with external researchers. Let's first take a look at some examples of what we've been working on. DSM 7.0 implemented what we call low-privileged system design. This minimizes the number of processes that run at the root or the highest privileges. What does this mean? Root accounts have the highest access right on the system. Simply put, anything that has root access can do pretty much anything. Access files, change settings, install something, remove apps, upgrade the operating system, wipe the operating system, or even flash low-level firmware to the hardware. It's the master key. For example, most PCs run at full administrative access to give users the permission to do whatever they want. One of the most noticeable changes is that DSM 7.0 prohibits packages that request root permission. This reduces the possibility that malicious packages can very easily take over the system. And this is great for helping improve third-party application security. Speaking of third-party applications, there are many challenges when dealing with open source projects. Most products contain a huge amount of open source code, like Microsoft, either libraries, frameworks, or individual code snippets. Being pre-built, these can significantly reduce development time, but often also introduce many dependencies. Which means additional issues can arise if developers are not mindful of the download origin of their components or their version numbers. Such a lack of uniformity adds complexity that can be difficult to track and manage. On large projects like DSM, source code management is a huge challenge, especially when tracking security vulnerabilities for both proprietary and open source code. Synology developers need to track changes made, auditing code for open source projects and their updates, track their dependencies, which sometimes require more tracking and auditing for their dependencies. Why is this a big deal? Recently, there have been an increase in open source supply chain attacks. Therefore, we've introduced the SBOM into our development pipeline. SBOM is a software bill of materials, which is the complete list of components in a piece of software. It describes everything that is used, each open source project, its dependencies, dependencies of that, and so on and so forth. SBOM makes it clear in what goes into what piece of software, what version it is, and what it might be linked to. Kind of like how some foods have a QR code to track where it was made or how it was delivered. This enables a very systemized way to document, organize, and ultimately monitor even massive amounts of code, which gives more transparency in the code, makes it easier to monitor potential issues and avoid them, makes it easier to understand the scope of code that needs to be patched, updated when something does happen, which means less time needed to find and fix issues, and therefore less time devices stay vulnerable. In conclusion, SBOM brings a lot of transparency and added agility into the entire software lifecycle process. However, to stay ahead of the curve, we obviously need to modernize our approach taken to security. Within DSM 7.0, we've modernized the protocols being used. Support for TLS 1.3, adoption of the noise protocol framework, and adding preemptive systems such as automatically blocking malicious connections. So starting with Transport Layer Security, or TLS. 1.3 is an important new revision that significantly strengthens one of the most important encryption protocols that we use in practically anything we do through the internet. The newest version drops many older and more vulnerable algorithms. In DSM 7.0, in addition to supporting it, you can actually set it to only allow it for connections. When enabled, DSM will ensure that the entire chain of connections between the NAS and your browser is encrypted, using the best available protocol we have, which would be TLS 1.3. This setting helps prevent security demotion attacks that take advantage of insecurities or weaknesses in older protocols and their encryption and cipher suites. This works great, especially if your devices are generally modern and up to date. Something we also did was employ the noise protocol framework. Now, what exactly is it? Simply put, noise is a set of rules, or its name, framework, that enable systems to create secure communication channels through certain predefined methods and protocols. Using noise helps increase transport security by being less susceptible for replay attacks, having perfect forward secrecy, being content agnostic, and not revealing the client's identity through encrypting metadata. For example, let's say you're in a cafe, using the public, unencrypted Wi-Fi to browse the web. Any unencrypted traffic over this connection can easily be intercepted by anyone on that network. HTTPS, which uses TLS, is a more familiar form of transport security, is able to prevent others from knowing the content of, say, web pages that you're visiting, which is important for something like banking, when you're paying for something with a credit card, and obviously for keeping things like your files and instant messages private. The tricky thing about good old HTTP, and by extension TLS, is that there are many different possibilities and implementation methods that you are not probably always as secure as you want to be. For example, websites may load certain elements over HTTP, and not all implementations support perfect forward secrecy. Noise, on the other hand, can always ensure all of this, because it's both simultaneously more rigid, yet simpler and much more modern. Meaning developers, it's much easier to create something secure. So back at the cafe, if you're connecting to your NAS at home or at the office, our noise implementation keeps your connection private and secure, preventing MITM attacks and greatly reduces the amount of data that can be compromised should someone even try to record the data and save it until we have the computing power to break some of the most resilient algorithms we have today. Noise has already been proven to be secure and has been adopted by products such as WhatsApp, WireGuard, Slack's Nebula project, and of course, now DSM. Noise protocol framework improves transport security, which is only one part of the big picture. DSM 7.0 also adopts PKCE, Proof Key for Code Exchange, also pronounced as PKCE, which is a new, more secure authorization flow based on OAuth 2.0. Now, even if you haven't heard of OAuth, you probably used it many times before. Whenever you log into a particular website or service using a third-party account, such as Google, Apple, Facebook, and so on, the service you are logging into is likely using OAuth to securely sign in. So what exactly does PKCE solve for OAuth? Essentially, PKCE helps prevent the leakage of credentials when you authorize something to log in on your behalf. This can be an app or a browser pop-up. For an app, let's say our Photos app, you are essentially passing a set of credentials to it to log into your NAS, obviously without typing it every single time. To keep this safe, we're not storing a plain text password, but rather an authorization code. Basically, after the first login attempt, if successful, the server will pass back a token that can be reused later without using the actual password. In certain cases, however, this can be intercepted in what is known as an authorization code interception attack. A malicious application can steal and reuse the code. PKCE solved this by introducing checks to the process so that each client needs to prove they actually own the token. One place where PKCE has been implemented is for the Synology account authorization process in DSM. This means that for devices with, for example, Synology DDNS, Active Insight, or C2 storage connected, the entire credential exchange process is much more secure and less susceptible for being maliciously intercepted. Another is Secure Sign-In. Introduced with DSM 7.0, our new app enables multi-step authentication and approved login. It leverages PKCE to securely provide either passwordless login or to be a second step. In addition to that, Secure Sign-In also introduces FIDO2 support to enable USB security keys, Windows Hello, and macOS Touch ID to be your second step authentication. Soon, we will be providing several new features. Abnormal login detection. Through the application, we'll provide time, location, devices info when detecting abnormal events. And when something does happen, a new password change reset session flow for abnormal login. Notifications on wearable devices, receive notifications on wearable devices, and support background approval on Android devices. Added support for Synology account login integration, which becomes more important now with new C2 applications. So let's take a look at a short demo of these new features. So here we have a secure sign-in enabled NAS, which will prompt us to approve the sign-in process as an added security process. In our next update, this prompt can now be approved on your Apple Watch or Wear OS device. And on Android devices, the process can be faster thanks to new support for background approval. And when suspicious logins are detected, Secure Sign-In will notify you and present you the option to change your password. After we completed the process, we can also choose to remove all active sessions to ensure maximum security. We also recently upgraded Synology account to support Secure Sign-In. With your Synology account now being tied to more and more services, such as Active Insight or our brand new C2 services, it's more important than ever to have a secure but convenient solution to add another layer of protection. One last thing we're going to discuss about new implementations are some preemptive subroutines. An old but extremely important security feature baked into DSM is the auto-block functionality. It used to be fairly simple. A client would be banned for a defined period of time after a specified amount of failed authorization attempts were recorded within a specified time frame, such as 5 failed logins within 5 minutes would get you banned for 30 days. This was great, but with larger and more sophisticated botnets with more and more IPs to throw at you, we introduced account protection, which basically locks down the user accounts under attack. In DSM 7.0, we're making the entire system a bit more capable by introducing fleet-wide deny lists. Known malicious IPs will be identified by our security teams to be distributed to all DSM 7.0 powered devices, of course, with internet connectivity. It acts in a way similar to antivirus updates and can quickly be used to shut down attacks by making the whole fleet immune. We work with security researchers to help us discover potential issues and flaws in the system. In 2020, we worked with over 150 researchers, and since the start of the bounty program, 342. We paid out over $246,724 in rewards and sponsored Bound to Own this year in 2021. A well-run bounty program is important, so we're always updating the product scope and the rewards to encourage more and more researchers to join. This year, we also upped our operating system awards by 2 to up to $20,000. To summarize, for Synology, security and privacy are key pillars. Therefore, we keep making improvements to meet the high standards of both us and our customers. Organizational improvements to improve product security, leveraging new protocols to give you a more convenient and secure way of logging into your device, and a well-run bounty program to discover potential issues and flaws in the system. That's a wrap for this session. I would like to thank you all for joining me today.